Welcome back to another Master Classic Make Math Make Sense math video. I'm your host, Mr. Shalongo, coming to you from my classroom at Betty Fairfax High School. Shout out 7th period scholars for getting it done when I'm not there. This video goes out to you. Alright, today we're talking about interpret quadratic models. Let's go ahead and get into the first example today. Alright, I'm going to read through the question and then we'll figure out what the elements are that it's asking us to answer. Sergey watched a hovercraft take off from a platform. The height of the hovercraft in meters above the ground t minutes after takeoff is modeled by this following function. So we got this hovercraft that's lifting off and then landing again. The function is h of t equals negative 4t squared plus 8 times t plus 32. Sergey wants to know when the hovercraft will reach its highest point. Rewrite the following function in a different form, either factored form or vertex form, where the answer appears as a number in the equation. So we've got to figure out, based on based on what Siraj wants to know. So Siraj wants to know what the highest point is, and we know that factored form has to do with zeros, and vertex has to do with the max or the min. And when we think about the highest point in relationship to these two things, it relates more to the max or min than it does to a zero. So we know that based on that we want to write our answer in vertex form, which again is a times x minus h squared plus k. So we want to take this equation that is currently in standard form and we want to convert it to vertex form. Alright, so I've got the equation graphed in Desmos. I've got a decent zoom so I can see that parabola, and pretty much the strategy here is we're gonna recreate the same exact line, but we're gonna recreate it in vertex form. So in order for me to start, I can clearly don't have a line right now. In order for me to get that line, I've got to figure out what the a value is, the h value, and the k value. What do we know about vertex form? We know that the h value and the k value come from the vertex. So I'm gonna click on the vertex, and now we know what the x and the y value are, right? So we're going to put in the x value, which is the h value in our vertex form. So we got minus 1, and the y value is 36. So I'm going to replace k with 36. Now if I take away this a, you can see the graph that I have right now shares the vertex. So far I've got the element of this graph correct, right? But we want this graph right now that's currently opening up to open down, and in order to do that, we got to multiply this x by a negative on the outside. And now you can see as soon as I add that negative in, it's opening down, but it's still not exactly matching. So we've got to scale this. So in order to scale it, I'm just going to look to see what was the coefficient on the t squared term. It was negative 4. So I'm going to put a negative 4 in for where the a was. And as soon as I put that negative 4 in, you can see the graph perfectly matches up. So now I've got the graph matching up the original standard form equation, and I've got it in vertex form. Now a couple things I need to change. I need to make this a t, and the h of t part is already over there, so I'm just going to copy and paste this over. Alright, now that I've got the equation in, the second part is how many minutes after takeoff did the hovercraft reach its highest point. So it's talking about minutes here. Up in the problem, we know that t is minutes, and in Desmos, we know that t is x. So how many minutes did it take the hovercraft to reach 36 meters? It took 1 minute. So I'm typing in right here the x value of the vertex. I hit the blue button and we move on. Alright, here we have a second example. Alicia watched the drone take off from a bridge. The height of the drone above the ground is modeled by t in minutes after takeoff. The function that models this situation is h of t equals negative 3 t squared plus 12 t plus 96. Alicia wants to know when the drone will land. So she wants to know when the drone will land. Question 1, rewrite the function in factored or vertex form. We've got to figure out, based on what she wants to know, are we putting it in factored form or are we putting it in vertex form? Is she asking something that has to do with the max or the min, or is she asking something that has to do with zero, right? So when we think about the drone landing on the ground in this scenario would be a 0. So she's asking us to write this in a way that we can tell what the 0 is. So we've got to put this in factored form. So factored form is x plus u times x plus v. Alright, so I've got the equation graphed in Desmos. We can see the parabola here. We're putting this in factored form. We know that in factored form, the factors come from our x-intercepts. So I'm going to go ahead and click on the x-intercepts. We got -4 here, and we've got +8. And so when I put these numbers in for u and v, I'm going to put in the opposite of these numbers for u and v. So here I'm going to put in a +4, and since the x-intercept is +8 for v, I'm going to put in a -8. And the reason why I'm doing the opposite is, if you can remember, -4 creates the 0, so -4 creates the 0 here, and then for our second factor, 8 creates the 0. So when I create factored form, I'm taking the opposite of the x-intercepts when I put them in the parentheses. Now I can see that the x-intercepts match up, right? But there's still some more work to be done. We've got a graph that's opening up right now. So I'm going to look at the coefficient on the x squared term, which is -3, and I'm going to put that -3 in front of the factors, and you can see as soon as I add that -3 in, the graph matches up perfectly, which means that we have an equivalent equation here. So now we've successfully added this in factored form. When I copy this over though, I'm going to change the t's, the x's for t's, because the problem has t in the answer. Awesome. Second question here. How many minutes after takeoff does the drone land on the ground? Now with this particular part, there are 2 x-intercepts, but we know that the first x-intercept can't be a viable option here because there's no such thing as negative time. So it's clearly asking for the second x-intercept. How long does the hovercraft take to land on the ground again? It takes 8 seconds. Sorry, 8 minutes.